February 27th, 1943. Vemork, Norway, 3,000 feet above the Rjukan Valley. Joachim Runneberg crouched in knee-deep snow, hands trembling not from cold, but from the weight of what he was about to attempt. Below him, floodlights illuminated the Norsk hydro plant, a fortress carved into the mountainside where Germany was producing the one substance that could give Hitler atomic weapons before America. The 23-year-old Norwegian commando had studied the intelligence reports until he could recite them from memory. 30 German soldiers guarded the heavy water production facility. Minefields surrounded the approach roads. Searchlights swept the valley every 90 seconds. Guard dogs patrolled the perimeter. The plant itself sat at the base of a 600-foot cliff considered unclimbable by German security assessors. Every military expert who reviewed the sabotage plan had reached the same conclusion. This was impossible. What those experts did not account for was that Runneberg and his 5 companions were not soldiers attempting a military operation. They were Norwegians fighting for their homeland, about to demonstrate that impossible simply meant no one had been desperate enough to try. The mathematics of Hitler's nuclear program were written in the electrolysis chambers beneath them, where heavy water accumulated at the rate of 10 kilograms per day. At that production rate, Germany would possess enough deuterium oxide to construct a functioning atomic reactor within 18 months. The race for nuclear weapons would be decided not by the brilliant physicists in Allied laboratories, but by whether 6 men with explosives could destroy what the world's most powerful military machine considered impregnable. The collapse of German nuclear ambitions had begun 3 years earlier, though none of the participants understood it yet. September 1940. Copenhagen, Denmark. Professor Werner Heisenberg, Germany's most brilliant theoretical physicist and director of the Kaiser Wilhelm Institute's uranium project, sat across a cafe table from his former mentor, Niels Bohr, the Nobel Prize-winning physicist whose work had laid the foundation for atomic theory. The meeting, which Heisenberg would claim was innocent scientific discussion, and Bohr would remember as a disturbing recruitment attempt, revealed the scope of German nuclear ambitions. Heisenberg's carefully worded questions about uranium isotope separation and neutron multiplication betrayed that Germany was pursuing an atomic bomb with the full support of the Reich. Bohr, who had Jewish ancestry and understood exactly what a German atomic weapon would mean for civilization, maintained careful neutrality during the conversation. But his notes, smuggled to Britain after his dramatic escape to Sweden in 1943, would provide Allied intelligence with the first confirmation that Germany had an organized nuclear program. More crucially, Bohr identified the technical approach German scientists were pursuing. They were not enriching uranium-235 like the American Manhattan Project would later do. Instead, they were using heavy water as a neutron moderator in natural uranium reactors, a technically simpler approach that required massive quantities of deuterium oxide. This single insight transformed Allied strategy. Germany's nuclear program could be stopped not by defeating German physics, which was among the world's best, but by destroying their access to heavy water. The Vemork plant in occupied Norway was the only facility in the world capable of producing heavy water in militarily significant quantities. Built into the side of a mountain by Norsk Hydro in 1934 to produce fertilizer, the facility had been expanded after the German invasion specifically to support nuclear research. The electrolysis process, which separated heavy hydrogen from ordinary water through electrical current, was hideously inefficient. Processing 50,000 gallons of water yielded approximately 2 pounds of heavy water, but Vemork had access to unlimited hydroelectric power from the Rjukan waterfall and had been producing heavy water commercially for years before the war. German scientists calculated they needed approximately 5 tons of heavy water to construct an operational reactor. At peak production, Vemork could supply that quantity in less than 2 years. British intelligence first learned of German interest in Norwegian heavy water through the Norwegian resistance in early 1940. Professor Leif Tronstad, Norway's leading expert on heavy water production and former chief scientist at Vemork, had escaped to Britain after the invasion and provided detailed information about the plant's capabilities. His briefing to the Special Operations Executive in March 1941 laid out the strategic situation with mathematical precision. Germany has ordered Norsk Hydro to increase heavy water production to 3,000 pounds annually. This exceeds any conceivable civilian application. The only possible use for such quantities is atomic research. If they succeed in building a reactor, they will be able to produce plutonium. With plutonium, they can construct atomic bombs. The war will be lost not on battlefields, but in Norwegian mountains. The first attempt to destroy Vemork came in November 1942 and ended in catastrophe that demonstrated both the mission's difficulty and the Germans' determination to protect the facility. Operation Freshman consisted of 2 gliders towed by Halifax bombers, carrying 34 British Royal Engineers trained in demolition. The plan called for crash landing near Vemork, assaulting the plant, destroying the heavy water production equipment, and escaping to Sweden. Weather conditions over Norway were appalling. One glider crashed into a mountain, killing 8 men instantly. The other crash-landed miles from the target. German security forces captured the survivors, interrogated them, and executed all 34 under Hitler's commando order, which mandated death for captured special forces. The bodies were dumped in unmarked graves. The failure of Operation Freshman convinced British planners that conventional military assault was futile. The facility's location, the Norwegian terrain, and German security made parachute insertion followed by frontal attack impossible. What was needed was something the British military had never attempted: a sabotage operation conducted by Norwegian civilians who knew the terrain, could survive in winter conditions that killed trained British soldiers, and possessed the technical knowledge to destroy specific equipment without damaging the entire plant. This last requirement was crucial. Norsk Hydro employed Norwegian workers who would be killed if the saboteurs simply bombed the facility. The mission required surgical precision, not brute force. Lieutenant Colonel John Skinner Wilson of the Special Operations Executive Norwegian Section selected Joachim Runneberg to lead the operation in January 1943. Runneberg was not an obvious choice. At 23, he was younger than most of his men. He had no formal military training beyond the SOE course in Scotland. He was not the strongest, the fastest, or the most experienced Norwegian volunteer. But Wilson recognized qualities that mattered more than physical prowess. Runneberg possessed an almost supernatural calmness under pressure, the ability to make rapid tactical decisions without freezing, and the moral courage to abort a mission if success seemed impossible. This last quality was essential. Britain needed the heavy water destroyed, but not at the cost of Norwegian lives thrown away in futile gestures. The team Runneberg assembled reflected the desperate creativity required for the mission. Knut Haukelid, 30 years old, had been living in the Norwegian mountains for 2 years as part of the advanced resistance team codenamed Grouse. He knew the terrain around Vemork like his childhood home. Frederick Kaiser, 27, was a trained electrical engineer who understood the heavy water electrolysis process. Casper Edlund, 24, had worked briefly at a similar hydroelectric facility and could navigate industrial infrastructure. Hans Storhaug, 25, was a champion cross-country skier who could move through deep snow faster than most men could run on pavement. Birger Strömsheim, 23, possessed the steady hands of a watchmaker and the temperament to arm explosives while under fire. These were not elite soldiers. They were Norwegians who happened to possess exactly the skills required for an impossible mission. Training for Operation Gunnerside, as the mission was code-named, took place in the Scottish Highlands under conditions designed to replicate Norwegian winter. The men practiced moving through snow while carrying 100-pound packs. They memorized the VMORC plant layout from blueprints until they could navigate it blindfolded. They rehearsed the demolition procedure on mock-ups of the electrolysis chambers until they could place charges and set timers in under 10 minutes. Most importantly, they studied the German guard patterns, shift changes, and defensive preparations. Intelligence from the Grouse team, transmitted via coded radio, revealed that Germans had increased security after Operation Freshman. The garrison now numbered 30 soldiers instead of 15. Minefields had been expanded. Additional searchlights covered approach routes. Guard dogs patrolled continuously. But the intelligence also revealed a critical vulnerability that German security experts had dismissed. The gorge beneath the VMORC plant, considered unclimbable in winter conditions, was not patrolled. German assessors had concluded that no military force could navigate the 600-foot cliff in darkness while carrying equipment. This assumption was technically correct for military forces. It failed to account for Norwegian mountaineers who had been climbing in these conditions since childhood. The cliff approach, impossible for British commandos, was merely difficult for men like Renneberg and his team. The personal accounts of what happened on the night of February 27, 1943, revealed the human dimension beneath the strategic success. Joachim Renneberg, interviewed decades later for the Imperial War Museum's Oral History Project, described the descent into the gorge with vivid precision. We roped together and began climbing down around 8 p.m. The cliff face was covered in ice. Every handhold had to be tested. One slip would send all 6 of us into the river 600 feet below. Halfway down, Frederick lost his grip and swung out over the void. We held the rope while he found purchase on the ice. No one spoke. We had trained for this, but training in Scotland could not replicate the terror of knowing that failure meant not just death, but the success of Hitler's nuclear program. The crossing of the Mona River at the base of the gorge tested the limits of human endurance. February temperatures in the Rjukan Valley regularly reached -20 degrees Fahrenheit. The river, fed by snowmelt from the plateau above, flowed with such force that falling in meant certain death from hypothermia within minutes. Knut Haukelid's account, recorded in his post-war memoir, Skis Against the Atom, described the crossing. We linked arms and entered the water. The current tried to sweep us downstream. The cold was beyond anything I'd experienced. I could feel my legs going numb. Hans lost his footing and we had to drag him across. We emerged on the far side and kept moving. Stopping meant freezing. We had no time to change into dry clothes. The climb up the far side began immediately. The ascent of the cliff on the VMORC side represented the mission's physical climax. The face was steeper than the descent, and ice covered every surface. The men carried 100 pounds of equipment each, including explosives carefully wrapped to prevent moisture contamination. Birger Strömsheim, climbing point position, found handholds by memory rather than sight. The floodlights illuminating the plant above created just enough glow to see the cliff face, but not enough to identify safe routes. His account, preserved in Norwegian military archives, captured the psychological strain. I climbed for 2 hours, testing each grip, each foothold. Behind me, I could hear my companions breathing hard. We could not speak. German sentries stood 200 feet above us. One shout would bring machine gun fire. I remember thinking this was how we would die, frozen to a cliff face in the darkness, never knowing if our families would learn what happened to us. The team reached the railway track that ran along the top of the gorge at 11:45 p.m. They had been moving for nearly 4 hours and were soaked, exhausted, and beginning to experience the early stages of hypothermia. Standard military doctrine would have called for rest and warming before proceeding. Renneberg understood they had no such luxury. The guards changed shifts at midnight. They had 15 minutes to cover the final 150 yards to the plant entrance, penetrate the facility, place the charges, and escape before the new guards discovered them. He signaled his men forward. The penetration of Wehrmacht's perimeter demonstrated how meticulous planning could overcome superior defensive positions. The intelligence from the grouse team had identified a cable tunnel that ran from the railway track into the plant basement. The tunnel was locked with a simple padlock that German security considered adequate because the entrance was visible from a guard tower 100 yards away. What Germans failed to account for was that Norwegian saboteurs approaching from the gorge side could reach the tunnel entrance by crawling beneath the sight line of the guard tower. Casper Eidland picked the lock in 90 seconds, while the others maintained absolute silence. The team entered the tunnel, closed the door behind them, and found themselves inside the facility they had studied for months. The layout of Wehrmacht's heavy water production cells proved exactly as Professor Tronstad's blueprints indicated. The facility contained 18 electrolysis chambers arranged in 2 rows, each chamber standing 6 feet tall and connected by pipes to the next in sequence. The chambers operated continuously, separating deuterium from ordinary hydrogen through electrical current. German engineers had added security measures since Tronstad's escape, including a steel door with additional guards, but the basic configuration remained unchanged. Frederick Kaiser, the electrical engineer, identified the critical chambers within seconds. "We need to destroy cells 10 through 18, he whispered to Ronneberg. "Those contain the highest concentration of heavy water. Destroying them will set their program back by years." The placing of charges demonstrated the specialized training that made the mission possible. Each saboteur had practiced the procedure hundreds of times on mock-ups in Scotland. They worked in pairs, one man placing plastic explosives while his partner unwound detonation cord. The charges had to be positioned precisely to rupture the chambers without causing explosion that would kill Norwegian workers in adjacent areas. The fuses had to be set long enough to allow escape, but short enough to prevent discovery by guards. Ronneberg supervised while glancing at his watch. 4 minutes had elapsed since entering the plant. The guard shift would change in 11 minutes. If they were still inside when new guards began their rounds, the mission would end in firefight that would likely kill everyone. The moment that defined the operation's success came at 12:03 a.m. as Ronneberg armed the final fuse. A Norwegian night watchman, Johansen, entered the heavy water production room on his rounds. He stopped, stared at the armed saboteurs surrounded by explosives, and faced an impossible choice. He could raise the alarm and save the German facility but doom his countrymen. Or he could stay silent and become complicit in sabotage that would bring terrible German reprisals against Norwegian civilians. Knut Haukelid's account described the encounter. Johansen looked at us, looked at the charges, and understood everything immediately. We expected him to shout for guards. Instead, he asked in Norwegian, "Is it the English?" I told him, "No, we are Norwegians." He nodded and said, "I will finish my rounds slowly." Then he walked out. That man saved the mission. If he had hesitated even seconds, we would have been forced to kill him or be discovered. The escape from Wehrmacht required navigating the cable tunnel back to the railway track, crossing 150 yards of open ground to the cliff edge, and descending into the gorge before the explosives detonated. Ronneberg set the fuses for 30 seconds, knowing this gave them barely enough time but reduced the risk of discovery by guards. The team moved at a running crouch, reaching the tunnel entrance as the first fuse triggered. The explosion, muffled by the plant's concrete construction, sounded like a dull thump rather than a detonation. Strömsheim, last man out of the facility, looked back and saw German guards running toward the heavy water building. Then he was over the cliff edge, rappelling down the face while the alarm sirens began to wail. The aftermath of the explosion revealed the precision of the sabotage team's work. German engineers examining the damage found that all 9 target chambers had been completely destroyed, spilling approximately 1,400 pounds of heavy water. The explosion had been precisely calibrated to rupture the cells without causing fires or structural damage to the building. No Norwegian workers were injured. The demolition was so surgical that German investigators initially suspected the damage resulted from equipment failure rather than sabotage. Only when they discovered the cable tunnel entrance forced open and found British-manufactured detonators did they realize they had been penetrated by Allied special forces. The German response demonstrated both the strategic importance of Vemork and the limitations of military power against determined saboteurs. Wehrmacht commanders deployed 3,000 troops to hunt the sabotage team across the Hardangervidda Plateau. They used dogs, skis, and local collaborators to track the Norwegians through the mountains. The search continued for 2 weeks, covering 200 square miles of the most inhospitable terrain in Europe. They found nothing. Runneberg and his team, moving on skis through blizzards that grounded German aircraft, covered 250 miles to the Swedish border in 18 days. They arrived exhausted, frostbitten, but alive. The entire team survived. German commanders, accustomed to crushing resistance through superior firepower, discovered that 6 Norwegians who knew the mountains could disappear more completely than an army could hope to find them. The strategic consequences of the Vemork sabotage extended far beyond the immediate destruction of heavy water supplies. German nuclear scientists, assessing the damage in March 1943, calculated that rebuilding production capacity would require minimum 6 months. Professor Kurt Diebner, scientific director of the Reich's nuclear program, reported to Albert Speer that the delay made atomic weapons impossible before war's end. His memo, captured by Allied forces in 1945, revealed German understanding of their failure. The destruction of our heavy water stockpile at Vemork has dealt a severe blow to the uranium project. We can rebuild the facility, but we cannot recover the time lost. American and British nuclear programs, which we estimate are 12 to 18 months behind our progress, may now achieve parity or even advantage. More concerning, the sabotage demonstrates that our security cannot protect facilities in occupied territories. Any rebuilt production will face the same vulnerability. But Germany refused to abandon the nuclear program. They rebuilt Vemork's heavy water production, increased security to 200 German soldiers, installed additional floodlights, and began accumulating deuterium oxide once more. By November 1943, they had produced approximately 800 pounds of heavy water and planned to ship the entire stockpile to Germany for reactor experiments. Allied intelligence, monitoring Norwegian resistance reports, learned of the shipment plan through Professor Tronstad in London. The decision to destroy the second heavy water stockpile created the mission's most controversial moment and revealed the ruthless calculations required to prevent Nazi nuclear weapons. Knut Haukelid, who had remained in Norway after Operation Gunnerside, received orders from London in January 1944 to destroy the heavy water shipment by any means necessary. The Germans planned to transport the deuterium oxide by railway to Lake Tinn, then ferry it across the lake aboard the civilian vessel DF Hydro, a passenger and cargo ferry that made regular crossings. Haukelid faced a moral choice that would haunt him for the rest of his life. He could attack the railway shipment, which would bring massive German reprisals against Norwegian civilians, or he could sink the ferry, which would kill innocent Norwegian passengers who had nothing to do with the war. Both options guaranteed civilian deaths. The only question was how many and who. The account Haukelid provided in his debriefing to SOE, preserved in British National Archives, revealed the psychological weight of the decision. I studied the ferry schedule and discovered that the early morning Sunday crossing carried fewer passengers than weekday runs. Perhaps 10 to 15 civilians would be aboard instead of the usual 40 to 50. I calculated that sinking the ferry would kill those 15 innocent Norwegians but would prevent Germany from obtaining nuclear weapons that could kill millions. The mathematics were brutal but clear. I obtained 19 pounds of plastic explosive and began planning to sink DF Hydro in the deepest part of Lake Tinn, where salvage would be impossible. February 20th, 1944. DF Hydro departed Mel with 53 passengers and crew aboard, carrying 15 heavy water drums in its cargo hold. Haukelid's charges, placed in the bow section and timed to detonate when the ferry reached the lake's deepest point, exploded at 10:45 a.m. The vessel sank in 3 minutes. The water temperature was 39 degrees Fahrenheit. 26 people died, including Norwegian civilians who had boarded the ferry for ordinary travel. Among the dead were women and children. The heavy water drums, each weighing approximately 50 pounds, sank to the bottom of Lake Tin in 300 feet of water, where they remain today. Too deep for salvage, even with modern equipment. The moral complexity of the hydro sinking generated debate among Allied leaders that continued after the war. Winston Churchill, informed of the civilian casualties, wrote in a private letter that the action was regrettable but necessary given the stakes. American nuclear scientists, learning of the sabotage through intelligence channels, expressed relief that German research had been disrupted, but discomfort with the methods employed. Leif Tronstad, who had authorized Haukelid's mission, never fully reconciled himself to the deaths of his countrymen. His diary entry from March 1944 captured his anguish. "We have killed innocent Norwegians to prevent something that may never have succeeded anyway. The Germans may not have been able to build a reactor even with the heavy water, but we could not take that risk. War forces choices that peacetime morality cannot judge. I pray the dead will forgive us." Knut Haukelid, who survived the war and lived until 1994, gave his final interview about the hydro mission in 1993. His words reflected a lifetime wrestling with the consequences of that February morning. "I dream about those people sometimes, the civilians who boarded the ferry not knowing they would die. They were Norwegians like me, trying to survive German occupation, doing nothing wrong except being in the wrong place. I killed them. I tell myself it was necessary, that nuclear weapons in Hitler's hands would have been infinitely worse. But the dead do not care about strategic necessity. They are still dead because of my decision. I accept responsibility, I accept guilt, but I also accept that I would make the same choice again if faced with the same circumstances. That is what makes it unforgivable and unavoidable simultaneously." The technical assessment of Germany's nuclear program conducted after the war revealed that the Vemork sabotage and hydro sinking had achieved exactly what Allied planners intended. German scientists never obtained sufficient heavy water to construct an operational reactor. Werner Heisenberg and his colleagues, captured by American forces in 1945 and interned at Farm Hall in England, were secretly recorded discussing their failure. The transcripts, declassified in 1992, showed they had been approximately 18 months away from a working reactor in 1943 before the first Vemork raid. The destruction of their heavy water stockpile repeatedly, first by Renneberg's team and then by Haukelid's ferry sinking, prevented them from ever closing that gap. But the transcripts also revealed something more disturbing. Some German physicists had been deliberately slowing their progress, making technical choices that delayed reactor construction. Heisenberg himself, when informed that America had successfully detonated atomic weapons over Japan, expressed surprise not at American capability, but at American willingness to use such weapons. His private comments to colleagues suggested he had been operating under the assumption that physicists on both sides understood atomic weapons were too terrible to actually build. This moral calculation, if genuine, meant that Heisenberg had been engaged in his own form of sabotage, using his position to prevent rather than advance German nuclear capability. The question of whether he deliberately failed or simply failed remained debated among historians for decades. The contrast between American and German nuclear programs revealed the industrial dimensions that mathematical brilliance alone could not overcome. The Manhattan Project employed 130,000 people at facilities across the United States. Oak Ridge, Tennessee, processed uranium using gaseous diffusion in plants that consumed more electricity than most American cities. Hanford, Washington, produced plutonium in reactors the size of football fields. Los Alamos, New Mexico, assembled the world's greatest concentration of physicists and engineers to design weapons. The entire American effort cost $2 billion, equivalent to approximately $28 billion in modern currency. Germany's program employed perhaps 100 scientists working in scattered laboratories with limited resources and constant interference from competing Nazi bureaucracies. They never had a realistic chance of success, even without sabotage. But Allied planners, unable to verify German progress, could not risk assuming German failure. The recognition that Germany's nuclear program was probably doomed regardless of Norwegian sabotage does not diminish what Runneberg, Haukelit, and their companions accomplished. They demonstrated that strategic targets could be destroyed by small teams of highly motivated specialists when conventional military forces would fail. They proved that occupied populations could resist effectively when supported by Allied intelligence and training. They showed that impossible was a designation that could be overcome by men willing to attempt what experts considered suicidal. These lessons influenced special operations planning for the remainder of the war and established principles that remain relevant in modern asymmetric warfare. The post-war careers of the gunnerside team reflected the different ways men processed extraordinary wartime experiences. Joachim Runneberg refused to discuss the mission publicly for nearly 50 years, working quietly as a radio technician and living in suburban anonymity. He emerged from silence only in the 1990s when Norwegian television producers convinced him that the story deserved telling before all participants died. His interviews revealed a man uncomfortable with hero worship, insistent that luck played as large a role as skill, and haunted by the knowledge that 34 British soldiers had died attempting the same mission he accomplished without losing a single man. When asked if he considered himself brave, he responded, "I was terrified every moment. Bravery is not absence of fear. It is doing what must be done despite fear. We did what was necessary, because no one else could." Knut Haukelid wrote his memoir, Skis Against the Atom, in 1954 and spent the rest of his life defending the decision to sink the Hydro. He became increasingly isolated in Norwegian society as post-war generations questioned whether killing civilians could ever be justified. In his final years, he acknowledged the moral complexity but insisted the alternative would have been worse. People who criticize from peacetime comfort do not understand the choices war forces upon you. We knew civilians would die. We knew we would carry that guilt forever. But we also knew that letting Hitler obtain nuclear weapons would kill infinitely more. Moral purity is a luxury available only to those who do not have to make impossible choices. The German soldiers who guarded Vemork left their own accounts of the sabotage, revealing the psychological impact of being defeated by an enemy they never saw. Oberleutnant Wilhelm Schulz, security officer at the plant, provided testimony to German military investigators in March 1943. His report, captured by Allied forces in 1945, showed how completely the sabotage violated German assumptions about security. We considered the facility impregnable. The gorge approach was impassable. The perimeter was mined. Guards maintained constant vigilance. Yet somehow, Allied commandos penetrated to the production chambers, destroyed critical equipment, and escaped without our forces firing a single shot. Either our security assessment was fundamentally flawed, or we faced an enemy whose capabilities exceed our understanding. I suspect both are true. The technical legacy of the Vemork raid extended into Cold War nuclear programs in unexpected ways. When Norway developed its own nuclear research program in the 1950s, engineers rebuilt the heavy water production facility at Vemork, using lessons learned from wartime destruction and reconstruction. The plant operated until 1971, producing heavy water for civilian reactors worldwide. Some of the engineers who worked on post-war reconstruction had been present during the 1943 sabotage. They reported that German improvements made after the raid, including reinforced chambers and enhanced monitoring systems, actually improved production efficiency. The saboteurs had inadvertently identified weaknesses in the original design that peacetime engineers exploited to create better equipment. The intelligence network that made the gunnercide mission possible deserves recognition equal to the commandos who executed it. The Grouse team, Einar Skinnerland, Knut Haugland, Klaus Hellberg, and Arne Kjellstrup spent over a year living in mountain cabins, transmitting weather reports and intelligence while evading German patrols. They survived conditions that would have killed most men. Skinnerland remained in Norway throughout the war, operating a radio that transmitted critical intelligence to London while German direction-finding units hunted him constantly. He was never caught. His radio, preserved in Norwegian resistance museums, sent over 1,000 messages between 1942 and 1945, many of them providing targeting data for Allied bombers and intelligence on German military movements. The cost of Norwegian resistance extended far beyond the sabotage teams themselves. German reprisals for the Vemork raid included mass arrests, executions of suspected resistance members, and destruction of villages thought to harbor saboteurs. Norwegian civilians who had no connection to the operation died because German commanders needed to demonstrate consequences for resistance. The town of Rjukan, where many Vemork workers lived, was occupied by additional German troops who treated the entire population as potential saboteurs. Random searches, curfews, and interrogations became daily reality. Yet the Norwegian population maintained support for the resistance despite these consequences, understanding that collaboration with German nuclear ambitions would bring worse horrors. The strategic deception that protected Operation Gunnerside demonstrated Allied understanding that successful sabotage required more than physical destruction. British intelligence deliberately leaked false information, suggesting the commandos had escaped to Sweden by sea rather than by ski across the mountains. German search efforts concentrated along coastal routes while the actual sabotage team moved inland. Additionally, RAF bombers attacked Vemork in November 1943, causing minimal damage, but convincing Germans that Allied strategy relied on air power rather than ground infiltration. This deception caused Germans to invest in anti-aircraft defenses rather than counter-sabotage measures, leaving the facility vulnerable to Haukelid's ferry operation in 1944. The mathematical analysis of Nazi Germany's nuclear program conducted by post-war intelligence officers revealed that even successful completion of a reactor would not have given Hitler atomic weapons by war's end. A functioning heavy water reactor using natural uranium would produce perhaps 20 grams of plutonium monthly. An atomic weapon required approximately 6 kilograms. German scientists would have needed years, not months, to accumulate sufficient plutonium even if their reactor worked perfectly. This timeline meant that Germany would have needed to achieve reactor criticality by 1942 to have any hope of producing weapons by 1945. The Vemork sabotage in 1943 closed a window that was already largely shut. But Allied planners in 1943 could not have known this. They operated on the assumption that German nuclear science, which had pioneered fission research, might achieve breakthroughs that American scientists had not anticipated. The irony of the heavy water program was that American scientists at the Manhattan Project had concluded by 1943 that heavy water reactors were inferior to graphite-moderated reactors for plutonium production. The Americans built massive graphite reactors at Hanford that produced plutonium far more efficiently than any heavy water design could achieve. German scientists, isolated from international research and constrained by limited resources, pursued a technological dead end without realizing superior alternatives existed. Even if the Vemork sabotage had never occurred, German nuclear weapons remained improbable due to this fundamental technical miscalculation. The heavy water program was the wrong solution to the wrong problem, pursued with inadequate resources by scientists who did not realize they were already defeated by physics before saboteurs ever intervened. Yet the mission's success demonstrated that freedom required more than moral superiority over fascism. It required men willing to climb impossible cliffs in darkness, to risk death in freezing rivers, to accept responsibility for killing innocents to prevent worse horrors. Runneberg's team and Haukelid's ruthless decisions embodied the uncomfortable truth that defeating evil sometimes required tactics that peacetime morality would condemn. The civilians who died on the hydro did not sacrifice themselves voluntarily. They were sacrificed by others who calculated that their deaths would save more lives than they cost. This utilitarian calculus violated the fundamental principle that human beings should never be treated as means to ends. But war makes moral purity impossible and demands choices between evils of different magnitudes. The final assessment of whether the Wehrmacht sabotage was necessary or merely dramatic cannot be made with certainty. German nuclear weapons remained theoretical possibilities rather than practical threats throughout the war. But the theoretical possibility justified extraordinary measures because the consequences of miscalculation would have been catastrophic beyond imagination. Runneberg climbed that cliff. Haukelid sank that ferry, and 26 innocent Norwegians died because Allied planners could not risk betting civilization's survival on the assumption that German physics would fail. The saboteurs operated on imperfect intelligence, made decisions with incomplete information, and accepted moral burdens that would haunt them for life. They did what they believed necessary to prevent Hitler from obtaining atomic weapons. History cannot definitively prove they were right, but it cannot prove they were wrong either. In 1993, the Norwegian government recognized Joachim Runneberg with the nation's highest civilian honor. At the ceremony, the 73-year-old former commando gave a brief speech that captured his perspective on the mission that defined his life. What we did at Wehrmacht was not heroic, it was necessary. Heroes act from courage and moral conviction. We acted from fear and desperation. We were terrified young men who understood that failure meant our families, our country, and perhaps the world would suffer under Nazi nuclear weapons. We did not feel brave. We felt responsible. That responsibility carried us across the gorge, up the cliff, into the plant, and through the escape that should have killed us. I'm honored by this recognition, but I accept it on behalf of all Norwegians who resisted occupation, including the 34 British soldiers who died attempting what we accomplished, and especially the innocent passengers on the hydro whose deaths purchased our success. They are the ones who truly sacrificed. We merely survived. The Wehrmacht plant stands today as a museum. The electrolysis chambers that once produced heavy water for Hitler's nuclear program, now preserved as monuments to Norwegian resistance. Tourists can walk through the facility, see where Runneberg's team placed their charges, and understand the physical dimensions of what those 6 men accomplished. But the museum cannot capture the terror of descending that cliff in darkness, the cold of the Mona River crossing, or the moral weight of decisions that traded innocent lives for strategic advantage. Those experiences died with the men who lived them, leaving only documents, interviews, and the knowledge that impossible simply meant no one had attempted it yet. The story of how Hitler's nuclear program was destroyed by one Norwegian's impossible sabotage mission is ultimately a story about the limits of military power and the potential of human determination. Germany possessed superior physics, adequate engineering, and unlimited political will to obtain atomic weapons. What they lacked was the ability to protect their heavy water supply against men who understood that some things mattered more than survival. Runneberg and his companions demonstrated that strategic facilities could be destroyed by tiny teams when conventional armies would fail. Haukelid proved that moral certainty was a luxury unavailable to those making life-and-death decisions in wartime. Together, they showed that wars are won not just by superior resources or better technology, but by individuals willing to attempt what experts consider impossible and accept consequences that peacetime conscience would reject. The final irony is that the Vemork sabotage probably prevented a nuclear program that was already failing for reasons the saboteurs never knew. But that does not diminish their achievement. They acted on the information available, made rational decisions based on imperfect intelligence, and succeeded against odds that should have ensured failure. Whether their success prevented catastrophe or merely accelerated the inevitable cannot be known with certainty. What is certain is that 6 Norwegian commandos climbed an impassable cliff, penetrated an impregnable facility, destroyed equipment critical to Hitler's nuclear ambitions, and escaped to tell the story. In a war filled with impossible achievements, the Vemork raid stands as proof that impossible simply means difficult enough to require exceptional people willing to pay exceptional costs. Those people existed. They climbed that cliff, and they changed history in ways that continue to resonate decades after the last electrolysis chamber fell silent.